Hey everybody, welcome to Algebra, Section 4.3, Writing Functions. By the end of this lesson, you should be able to write a function rule from a table, from ordered pairs, even from a story problem. You should be able to identify the independent and dependent variables from a story problem. You need to be able to use and understand function notation, and also evaluate functions. So let's get to it. Okay, so when we say write a function rule, that basically means write the equation. So we're going to be able to take a look at these tables, these ordered pairs, and be able to write the equation from those. So what I want to do is I want to be able to spot the pattern. What do I have to do to my x values, my input, my domain? What do I have to do to those to get those to turn in to my y values, my output, my range? So if I take a look here, what do I have to do to 8 to get it to turn into negative 24? Well, I could subtract 32. Let's see if that pattern holds up. If I do 6 minus 32, is that negative 18? No. So that's not the pattern I'm looking for. What else can I do to 8 to get it to turn into negative 24? I could multiply it by negative 3. Let's see if that pattern holds up. So 6 times negative 3 is negative 18. 4 times negative 3 is negative 12. 2 times negative 3 is negative 6. 0 times negative 3 is 0. There we go. That's the pattern, multiplying by negative 3. So I can write negative 3 times x will equal my y value. And that's my equation. So basically figure out what do you have to do to the x to get to the y. Let's take a look at this one. How do I go from 8 to 14? Let's see, I could add 6. Let's see if that pattern holds up. 6 plus 6 is 12. 4 plus 6 is 10. 2 plus 6 is 8. 0 plus 6 is 6. So that's my pattern, is adding 6. So I take whatever my x is, I add 6, and that will give me my y value. Not too bad. It's not always going to be that easy, though. So let's take a look at this one. What do I have to do to 0 to get it to be 1? Well, I can add 1. Does that pattern hold up? 1 plus 1 is not 4. All right, 2 plus 1 is not 7. Let's see here. What can I do to 1 to get it to be 4? I can multiply by 4, but is 2 times 4 7? No. Is 3 times 4 10? No. So there might be a couple things that I have to do in order to get this. Let's see, 2 to 7. Let's see, what if I multiplied it by 2? 2 times 2 is 4, and then add 3. Okay, let's see if that pattern holds up. What if I take 3? So 2 times 3 plus 3. Let's see, that's going to be 6. That's going to be, add 3 makes 9. That's not the pattern. Okay. What if I multiplied by 3? So 2 times 3. Okay, I'm looking at the 2 and the 7. So 2 times 3 is 6, and then to get to 7, I add 1. Okay, let's plug in 3. 3 times 3 plus 1, that's 9 plus 1, that's 10. All right, I might be getting somewhere. Let's see if it works for the other ones. 1 times 3 plus 1 is 3 plus 1 is 4. And 0 times 3 is 0 plus, okay, I think I found it. So I take whatever the x value is, multiply it by 3, and then add 1. So take whatever the x value is, multiply by 3, add 1, and that's my y value. So I had to do some guessing and checking, and it kind of took a little bit, but I eventually found it. So I had to do multiplying and adding in order to get to that answer. Okay, let's try another one. This one's not going to be so easy. Let's see. 1, well, right here, it's the same number. So 0 and 0, 1 and 1. So 2 and 2, oh, it's 2 and 4. So it's not that x equals y. They're not the same number. See, negative 1, 1. So what do I have to do to 2 to get to be 4? I can multiply by 2. Does that hold up? 3 times 2 is 9? Nope. Okay. I could add, nope, that's not going to work. Wait a second, I'm noticing a pattern here. 1, 4, 9. Those are the perfect squares. Okay, what if I take the x value and multiply it by itself? So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 0 times 0 is 0. Negative 1 times negative 1 is a positive 1. So there we go. That's my pattern, is I take the x value and I multiply it by itself. I square it. So those are some kind of tricky ones, but that's what we have to do, is we have to keep guessing and keep checking until we find the right pattern. Let's also see if we can use a story problem and write an equation. So it says a taxi charges $5 with an additional $1.25 per mile. So first thing I want to do is I want to identify my variables. What are the things that could possibly change in this story? How many miles I go, that's a variable. And we're talking about money here, so the total charge that they charge me. Now, something else I want to do during these story problems is not only write the equation, I want to identify what's the independent and dependent variable. Okay? So which thing happens first, which causes the other thing to change? So if I'm getting into a taxi, do I go the miles first and that causes the price to change? Or does the price change in order to fit the miles? Well, anyone who's been in a taxi know that you drive first and then you pay. So the number of miles is independent. And then the price, the total charge, depends on how many miles you went. So the number of miles is independent. And the total charge is dependent. It depends on how many miles you go. Okay, so let's take a look at the independent.